Okay. Amanda, are you recording?
Am I recording? No.
I'm recording to this computer, okay?
Okay.
Okay. Okay.
Perfect.
Amanda, are you recording? I said I have to silence it. Okay, go ahead, Amanda.
Okay. Hi, guys. Thank you for joining. This is Essence of Science. Today we're going to be talking about the technology that takes us over the clouds. I'm Amanda Armagost.
I'm Dr. Abbasi for Essence, and we have a special guest today. Amanda, who's our special guest?
We have a special guest. His name is Andy. He's actually an aviation specialist. He's going to give us a lot of information about the technology behind flying, the history behind flying, and what we think the future will be.
And, I can tell for myself that the dream of every little boy is becoming a pilot. Now, it goes between being a rock star, an astronaut, and a pilot, right, Andy?
Yes, exactly. Yes. In fact, I come from a family of flyers. My father was Royal Air Force. He joined when he was 16 and had an amazing 22-year career. In fact, he was in the air in a Vulcan bomber during the Cuban Missile Crisis, flying over Western Europe, just waiting
Wow.
for the order. He was literally on the front lines of that moment. So, his stories are fantastic because he really comes. He came out of the Second World War developments of aircraft. Was probably one of the biggest aircrafts, rockets, missiles. Was probably one of the biggest advancements coming out of the Second World War, and aviation exploded after that because it produced the jet engine, and really the introduction of the jet engine just changed how people completely view aerospace. It made international travel a lot quicker, a lot safer. It was just amazing, and it just exploded after that. And you make mention, Dr. Abbasi, that a dream of little boys is to become a pilot, and my brother did. He became a commercial pilot. He followed in my dad's footsteps into the air. Personally, I decided to stay on the ground. That was a safer choice, really, for me and everyone else involved. I just didn't have the discipline to be a pilot when I was younger.
I think I disagree with that. I don't believe you are not disciplined, because we know for every hour that a pilot flies, there are like 50 hours of people behind him.
Yes.
That airplane fly worthy. So, but you
Absolutely.
gave already 5 ideas about. I want to have your dad on this podcast if he's available to talk.
Brilliant.
To talk about his experience of that, especially Amanda put on that on our Essence of History. We need to talk about Cuban Missile Crisis. That is something that we should need to revisit. But more importantly, you went through so many things so fast, like jet engine and so on and so forth. Now, an airplane, it needs an aerodynamic kind of thing, whatever that is, and something that can push it. Correct?
Yes.
You need something.
Basically, that's it. Yeah. All you're trying to do is create more pressure under the aircraft than you are above it, and mainly on the wings. That's everything. That's lift.
So,
and the bigger the wing, the more the lift.
Yeah. If I may ask, you have the Da Vinci drawing from 1600, that flying thing and so on, multiple, even helicopter and so on. What was the problem? So it took like 300 years before we could fly. Why couldn't we fly sooner?
Power. Strictly power. We could not produce power in enough of a consistent mode to be able to fly. And the Wright brothers' first flight was only 12 seconds.
Yeah.
But from there, they were the ones that proved the wing. And after that, it was up to the rest of the world to build the engines that could develop it, and also the structural frame of the aircraft to be able to handle the engine.
And now, I'm always surprised that when I get in an airplane, I'm in shock and awe. That big thing, like we get in a Boeing 747, you talked about that the Wright brother, their first flight was shorter than the Boeing is long.
Yes, it is amazing. And you look at those aircraft. And in fact, I live in Wichita, and we have a place called NIAR Works here. And NIAR is the National Institute of Aeronautical Research. And I was over there a little late last year, just visiting some friends on a day off. And they're actually converting a 777 aircraft to be a cargo plane. It used to be a commercial passenger jet. And it was the first time I was that close to one. And I mean, just the wheels are 6 feet high. The landing gear, the size of the landing gear was enormous. And you just look at this thing and you think, how?
Exactly.
But all the principles, whether it's a little tiny Cessna 172 or it's a 777, the physics are all the same. It just depends on the bigger you build it, the bigger the engine, the more the push, the bigger the.
But I hear as well, bigger airplanes are overall they are more efficient. I hear, is that true?
I think the jury's out on that. Where I would say I think the efficiency is really coming in is the engine design. I was on a program with Bombardier called the C Series, and it was our first and only foray into the commercial realm that is owned by Airbus and Boeing. And we had produced such an amazing aircraft that Boeing and Airbus, they went crazy. They were trying to upgrade their A219s, the 737. They called it the 737 Neo, I believe. But they couldn't touch the C Series because the engine that was developed by Pratt & Whitney for that had a 12-to-1 bypass ratio.
Do you want to explain that? Because I don't believe everybody understands that what you just said, bypass ratio. Explain that.
Right. So basically, the engine itself is going to produce so much thrust out the back, and that's really the exhaust. But what the engine is doing is it's driving the fan blades at the front, and it's the fan blades, and these were the diameter of the engine was 6 feet from the inside on the inside of the inlets. The actual core of the engine was maybe only about 18 inches wide. But those massive fans would bring an awful lot of the atmosphere into the engine so that the compressors could really push it down. And then that clean air that's pressurized comes out the back. So for every 1 unit of thrust from the exhaust, you get 12 units of thrust from the compressor. And because it had such a big compression ratio of 12-to-1, it not only made it very quiet, but it also made it incredibly fuel efficient.
Yeah.
Now, this engine was specifically designed for this aircraft. And when you look at it, it's now the A220. When you look at the aircraft, you'll see the wings start very steep out of the fuselage and then come across the top. And that was a specific design to allow those engines to be installed. Most wings come out pretty flat. This came out very tight.
Oh, there is a good story behind that, actually. That Max 77 Max, where they had to change the engine, but we've come back to that. Go ahead, please. I'm listening. Go ahead.
Yeah. So basically, this aircraft was just, I mean, it was hitting all the performance numbers and beating them, and ultimately because of financial situations and just the economy. If there's one thing that affects aerospace, the economy will take it down very fast. We found ourselves in a position where we ended up selling that program to Airbus, and it's now the A220. But with that engine, it was revolutionizing the industry. And when we first were coming out, it was actually the Trump administration. They put 125% tax levy against every C Series that would be sold in the States because it was going to be such an interrupter to Boeing. Now, we eventually won that case, and they couldn't put that levy on us, but they literally tried to stop us selling that aircraft in the United States.
That doesn't sound like a free market. That does not sound like a free market.
Yeah. No, but we won't get into that aspect of it, I don't think.
Yeah, that's a whole other conversation.
Yes. But the other part of the C Series that I personally found just incredible, because I hadn't been exposed to it, was fly-by-wire technology. I'd
Right.
heard about it.
Mm-hmm.
And honestly, I'm a mechanical guy. I absolutely, flight controls was one of the things I love most. It still is. But the old flight controls, you've got the control column at the front of the aircraft with the pilots, and you've got to get all those cables through the aircraft, around pulleys, all the way out to the ends of the wings, up to the top of the vertical stabilizer and the rudder for all of that. And you've got to do it so those work perfectly each time. And when I first got down to Wichita in 2000, I was on a program called the Challenger 300, now the Challenger 350.
Mm-hmm.
And it was one of the things as we built the first aircraft that absolutely fascinated me. You have all these, it's like a three-dimensional puzzle that has to work perfect when you're done. And I learned things like before you even put the cables in the aircraft, you have to stretch them, pre-stretch them for 72 hours at ambient temperature. So you put them in an air-conditioned room at 72 degrees and you stretch them to a certain amount, because if you don't do that, after they get used in the aircraft a few times, they would loosen and the pilot would start to lose control of the aircraft.
Wow. No, educate me a little. That big old 747.
Mm-hmm.
You're telling me the pilot sitting in the cockpit mechanically controlling the aileron and all the flight control levels, but that airplane is so heavy, so fast, so much power. How does one person produce enough force to control that mechanically?
And if you ever get an opportunity to look at the bottom of the control column, the part that's through underneath the floor, there is an immense amount of pulleys and adjustment levers and all kinds of stuff, so that it's like if you run a rope through enough pulleys, a single person could lift a ton object quite easily.
Archimedes.
And it's the same principle.
Yeah.
And that's how they do the flight controls. And you hit on a very key point. The flight controls have to be designed, they have to be installed, and they have to be finalized. That their functionality has to be confirmed to within certain amount of limits, pull limits for the pilots. And you have to account not just for a 6'1" dude like me, you have to account for a 5'2" lady as well, because ladies fly aircraft. So we, and a lot more of them are doing it, and it's a wonderful thing. So, you have to make sure that things like that are designed. And those old mechanical systems were so intricate and so clever that I just loved it. Every time they went out to put a new system in, there was flight controls, I just watched them do it. I just loved it. Now it's all wires and computers and little servos.
So number one, that must add a lots of weight to the airplane, having all those pulleys and cables and so on. And number two is that we had mechanical engines and electromotors for a very long time. We have hydraulic thing for a long time. What did it take us so long to go flight by wire? Because in some other industries, we know they have been doing it for a long time.
Mm-hmm. Okay. Well, whenever it comes to flying, everything is a 10th degree more difficult to design and certify. And when you get into fly-by-wire, you are now getting into very complex software and hardware systems. And it's airborne electric hardware, electronic hardware is one of the AEH is one of the acronyms we use. Nowadays, certifying a new box, a new black box, a new computer for an aircraft takes a significant amount of energy. And the components within there are not the components that you would see in your TV or in your cell phone. They are military grade units. They're designed and built so that they can take and withstand all kinds of environments, salt fog, or an aircraft might fly out of Los Angeles for a lot of its career, whereas another aircraft might fly out of Wichita for most of its career. Well, they're both going to endure different kinds of wear and tear. If an aircraft's parked next to the ocean for years on end and it's flying in and out, it's going to absorb salt. So all those boxes have to be able to maintain that so that they have a certain shelf life. And it gets very complex.
Right? there's lots of redundancy in the
Yes.
yeah. Now,
Yeah.
I want to go back to that, jet, the engine, but I love to come back to the flying part itself. Now, for general audience who don't understand that, we talked about you need aerodynamic structure and you need something to push it. For a long time, only thing we had to push it was a propeller. But propeller pushing the air, like a third law of thermodynamics or third law of motion by Isaac Newton, is you create a draft backward that push the airplane forward. Those propeller eventually become so fast and so massive that they're faster than the speed of sound, so you can only go so fast with propellers. But toward the end of Second World War, lots of people actually independently came out to find out that you can actually burn gases, fuel, and push them backward, and then the counteraction of that push the airplane forward. You can go so much faster. And for a long time, we just used that, burning the fuel backward and pushing the airplane forward. But until we noticed that actually, if we compress the air and so on and turn the shaft, that actually makes it more efficient. And then we found out this torque of the shaft can as well push a propeller that is inside of the engine. And then we figured out again and again, you can use a smaller part of the engine as a jet, but then push a bigger propeller, and that is the so-called bypass ratio, meaning that like there's some engine that now they have 30-to-1 ratio, meaning that for every 1 unit of air that goes back as a jet engine, the propeller is pushing 30 unit of air, and that add a lot to efficiency.
Absolutely, yeah.
As well add some other problem, like then it as well limits again that how fast you can go. So is that true that most of aviation industry for passenger, they want to go higher bypass, but in military that is limited because you do want to go very fast. So for people who don't understand the whole concept, so that the bypass ratio is, but flying by wire versus flying by pulleys and mechanical flying. I had a so-called Cirrus airplane that had something like a joystick. And I think the problem has been for a long time that, as you said, these pulleys and so on, they have been evaluated. They have been in existence for such a long time that we know everything to be known about them. And even when you have those structures in the rest of the industry, trying to certify something for flying it's such a big animal, such a different animal.
It's a huge task. It actually, the Mitsubishi, they tried to enter the regional jet market a number of years ago. Bombardier owned the regional jet market. In fact, Bombardier invented the regional jet market with the CRJ many years ago, back in '92 when we first did that. Mitsubishi tried to do the same thing in the 2000s, throughout the early 2000s, and I believe it was last year they finally shut down their program because they could not achieve FAA certification. They had gone into the program completely underestimating it, and they literally, the program is dead now.
And I think what you're saying is extremely important, because every time there is an airplane accident, almost anywhere in the world, is in the news.
Yes.
Right?
Yeah.
And the reason for that is so rare.
What about smaller? I thought like smaller planes crash more often than big planes.
They do. The thing with smaller private ownership is it's completely up to that owner as to how they maintain their aircraft, their skill level. A lot of people just go out, they go for joyrides, but they're not necessarily looking at proper weather patterns. They don't have the technology in the aircraft, like collision avoidance, terrain avoidance, weather radar, things that will give them warnings. And a very good example of this is John F. Kennedy Jr. What was it, 30 years ago, he left Martha's Vineyard with his wife and his sister-in-law, in a small Cessna. They were only flying across the bay, but they got caught in a storm and they disappeared. They were never found. And they believe what happened is they got so disoriented in the storm, because remember, they're just looking at little analog dials on the aircraft. They didn't know if they were upside down or not, and they flew right into the ocean and died. So with a commercial outfit, they probably would have never taken off, because they're going to be, they have a responsibility to passengers, whereas a family just has a responsibility to themselves. So with commercial flight, it has to be very, very tightly controlled. And yeah.
There is a joke among surgeons that those small airplanes are doctor killers. In fact, the doctor are killing themselves, especially the surgeon. Because in the war, this is I can tell you lots of surgeons who have died of plane accident while they were piloting themselves. In the war, you tell something, everybody listens to you, and everybody jumps to comply with all your wishes. Aerodynamic doesn't care that you are a very accomplished surgeon.
Even neurosurgeons.
Even neurosurgeons, that's right.
Yeah.
Those small airplanes are famous as doctor killers.
Yeah, I believe it, because every surgeon I've ever met seems to be a pilot. And after I met you on Wednesday, Dr. Abbasi, I had a chat with my dad, and he just fell apart laughing. He goes, every single surgeon we've known is a pilot. So it's a bug. It's a thing with you guys, for sure.
But most of us are better surgeons than pilots.
I hope so.
Yeah. Well, you see, the idea is here that being pilot for us is a hobby. Being a surgeon is our life, our profession, our vocation. So, and that it's a matter of experience. Like the 2 days before you and I met, every day I did 5 surgeries. Well, wow. I haven't flown for years now. So it is about the level of the experience and you bring to the table that makes you good at almost anything. Now, but there are many things that I teach in my profession to other surgeons that I took from aviation industry. Like there are rules that how you become a pilot. I'm sure there are lots of little boys are listening to us. What do you know about what it takes for a person to become a pilot, Andy?
Well, it's not cheap. And that's one of the main things. But what I am seeing recently, because there's actually been a glut of pilots coming through, there's a lot of schools that are popping up that are now offering pilots licenses, commercial pilots licenses, and even some of the airlines are now starting to get in on that, which I think is great, because we do need to really open it up again. We need to make sure that little boys and girls are looking at pilots as a real career that they can get into without having to spend a fortune. The easiest way generally is to find a really good local private pilots club and sign up for lessons. Generally, it's about $150 a flight hour plus your classroom. It's not awful, but if you can get your private pilot's license, that helps grease the wheels to move up to the other things. But at that point, you really need to be looking at a career path for it. If you're going to get your commercial, you're going in full bore on this. My brother, he went to a college in Thunder Bay, Ontario called Confederation College, which is actually where I went to. And they do a 5-semester straight through program. You get your private pilot's license, I think, by the end of the first, and you're a commercial pilot by the time you graduate in 2.5 years. He spent about 10 years in the outback of Canada, flying to the mines, flying gasoline into remote villages, flying to places where you either land on water in the summer or ice in the winter, right?
Do they call it bush pilots?
Bush pilots, Canadian bush pilots. There is no better pilot than a Canadian bush pilot.
Well, I have heard those bush pilots are the most skilled pilot. they can land almost everywhere.
Yes.
So tell me about them.
They're incredible. My brother had stories. Sadly, he did pass away 3 years ago. But my brother had stories from his time flying up in the bush that my mom still hasn't heard of. Maintenance on aircraft could be a little bit iffy. He had fuel panels installed with wood screws. He had the front cowl of an aircraft repainted, and the overspray was on the windshield. I mean, it's crazy. They some of these outfits, they just kind of duct tape these things together and they keep going.
Yeah.
But the flying they do, as you said, it's incredible because they're in such remote regions. My brother, he would fly into one mine. He would have it would be a Beaver, which is the workhorse of the Canadian aviation industry, and he'd have 55-gallon drums of gasoline behind him. So if he crashes, I mean, he's literally a bomb that's going to go boom. And he'd come in over the trees and he'd land on a frozen lake where the wingtips were only about 4 or 5 feet from the snowbanks that was so high because they had to plow down in there. There's 10 feet of snow on the ground. So he's landing on skis with all this gasoline behind him. In order to get out of that lake or off the lake, all that gasoline has to be unloaded. And even then, he's still just skimming the treetops getting out of there.
Yeah.
And that's the flying they do. And those pilots were also part of the Battle of Britain in 1939. And the Canadian pilots were some of the best and most recognized pilots because they came from the Canadian bush.
Yeah. Now, one thing about those bush pilots is that they maximize the landing and takeoff distance unbelievably. As a matter of fact, I have seen on YouTube some of those bush pilots, they land in a patch that is like just few meters and so on. Yeah. And I have landed airplanes, I'm just getting sweating just watching how they are using the element of the environment to their advantage to land in such a, but that is all special thing. In the aviation industry where you are, I think things are so highly regulated.
Yes.
So highly tested. So like I hear that that everything you produce, after certain time you have to take the whole engine apart, put it back together, and that's very expensive things.
Yeah.
So and every little piece in the airplane has a life expectancy that has to be maintained or rebuilt and so on. So what does it really take to make those big, like one of your Bombardier or one of your airplanes? By the way, yesterday I was flying in one of those airplanes to get from Wichita to Chicago. In one of your airplanes, yeah.
Oh, so, lovely.
Yeah, what does it take to make an airplane like that airworthy? Tell me on your side, what are the requirements?
Well, for us, I mean, my main focus has been experimental flight test. So as we're developing, as Bombardier is developing a new clean sheet design like the Global Express, the Challengers, the C series, we in experimental flight test, we're also building our own aircraft within that aircraft, and that is all the experimental equipment that's going to go in there. In order to get a new aircraft off the ground, there's thousands of parameters, both analog and digital, within the aircraft. And we go through an immense amount of testing just on system rigs and then on the aircraft level, just to build up to a first flight. Once we've got past first flight, we have to have, like you said, a regulated maintenance. But in experimental, a lot of what we're flying with is in development too. So we have a lot of restrictions and limitations against the aircraft that we slowly, as the software develops, as we correct issues that we find in flight test, those limitations and restrictions are slowly lifted until we get to the end of flight test, where at that point we need to have a certifiable aircraft that will be that can be produced, sent out into the world, and maintained properly on a regular basis. And the goal being the least amount of maintenance you can have them do and the more flying time. and I believe the industry standard is 98% or 99% dispatch rate. And dispatch rate is what companies like us are really keyed in on when we are producing a new aircraft, and especially when it goes out into the field, because its dispatch rate is going to determine whether or not the person that buys that aircraft is going to make any money from it.
Yeah.
Or
This
so
is-
it's really critical. So as we develop the aircraft, we're also developing the maintenance program, and we're also identifying any areas of the new aircraft where we're going to have to pay special attention, maybe make some extra modifications to it, so that when we get to certification and delivery, it's at the best condition it can possibly be in for the customer. And
No,
that's our challenge.
that is actually such an amazing job, and there are millions of parts I'm hearing that in a regular airplane that has to all work perfectly. Now, something not long ago, something went wrong in that whole process. I'm talking about 77 Max, no, 777 Max, right?
I think, was it the 737, the one that crashed?
Yeah, no, the one
Yes.
Indonesian, one Ethiopian airplane that
Yes.
crashed, and I have read a lot about that, but I want to have your take on that. So for people who are listening to that now, obviously Boeing had this fantastic new airplane that is very efficient, doing a great work, and so on. And what they do is that they want to compete with another airplane from the Airbus side,
Mhm.
and they have to change the position of the engine, change it a little, so they have to bring it a little up, and that
Mhm.
change the aerodynamic and give the airplane a little pitch the wrong direction. Their
Yeah.
solution for that is to bring a program, a software, to automatically compensate for that, and then that automatic program, lots of American pilots notice that, they turn it right off, and everything is fine. Because in US and in most of the Western countries, we trust our judgment better than a piece of technology.
Right.
In two airplanes, one in Ethiopia, one in Indonesia, that is my interpretation, that the fact is, by the time they turned it off, it was too late.
Yeah.
And then
Well, that safety software, I shouldn't even call it safety software. That critical piece of software was offered as an option. That should never happen. And I still am wondering where the investigation is between for the FAA and Boeing, who allowed a piece of safety software or any safety equipment to be offered as an option. Now, when North America and Europe buy aircraft, they basically buy them with all the options on, so it was there. But for those other countries, they hadn't bought that option, and I don't know how you certify something with a safety system as an option, and that's why unfortunately people died, and the 737 was grounded for I think about 3 years.
Yes, it was a big deal, big hit on U.S. industry, aviation industry, and so on. But would you mind to just describe from your side, what exactly did go wrong? This was my take on that, but what is your understanding? What was the problem, and why those two airplanes went down?
Well, for me, from my experience, there's so much money involved in the development of an aircraft, whether it's a new aircraft or it's just a derivative, where you're putting maybe new engines on it, you're putting a new avionics suite in it, and you change the number from a G6000 to a G6001, But either way, it's very expensive. And the problem is that far too often, especially in history, money has driven schedule. And that is the killer. I've been in situations where I've felt that marketing was maybe pushing too fast and pushing engineering and trying to push our development too fast, and overselling the aircraft at times. I think in this case with the 737, like I said, the C series had come out and it was kicking butt across the board. And both Airbus and Boeing were desperate to get out because the 737 was that was the aircraft we were targeting. And I think they pushed too fast. I don't want to say that there was some funny business going on, because I don't know if there was. I suspect that maybe there was, and some palms got greased that maybe shouldn't have. But I think they pushed a product out incorrectly. And
Cut
in some
corners.
cases, I think it could even be criminally.
Yeah.
And, because and on both sides, because the FAA that I deal with, you don't get anything by them. These people are in your business, and they need to be in your business. They need to be looking at what you're doing, and they need to have oversight. And they should only be delegating to a company to certify its own product on their behalf when they have absolute confidence. And I think that's something that maybe between the FAA and Boeing, there were people that were too comfortable with each other, that had maybe had too many years together, because something went very wrong there. I cannot imagine. First of all, I can't imagine Bombardier ever being in a position with the FAA like that. And secondly, I can't ever imagine my company pushing out a product that has a safety feature as an option.
Well,
I don't.
airplanes,
It still boggles my mind.
in each of those accidents, more than 300 people died.
Yeah.
This
Yeah.
kind of cutting corners does have consequences.
Absolutely. And in aviation, you die.
Yeah.
And the thing I tell it's as simple as that.
Yeah.
We in the last couple of years, Bombardier has created a defense organization that is just exploding, and we're taking out business jets, and we're militarizing them for surveillance aircraft and medevac aircraft, and if somebody wants us to do something to an aircraft and they're willing to pay for it, we'll do it. And what I've really seen is that sorry, I've kind of lost my thought there for a second, but the industry is growing so fast that we're bringing so many young people in. One of the first things I tell them is, every time you see an FAA regulation, remember that somebody probably died for that to be written. Right. Every single rule in there is because somebody got hurt, they died, or they died, or something awful happened.
And we learned that is the beauty in these disasters, that we never go a disaster without learning whatever we can learn from it, make it safer for the future. And that
absolutely. Yeah. And getting back to our original point, with the evolution of technology, that becomes even more critical.
Yeah.
Because, we're now turning aircraft, basically they're flying computers now.
Yep.
Like I was saying, flight controls, I love to watch the pulleys and tension adjusters and everything they had to do to put that system in and maintain that system, because they had to check the cable tension on a regular basis every few flights, make sure the cables hadn't stretched. But now it's all computers and wires, and it saves a lot of weight, as you mentioned. That was a very good observation. But it does put a lot more complexity into the software, into the hardware. I think our last aircraft we certified, which is the Global 7500, I think the number I heard was 27 miles of wiring in that aircraft.
Yeah, wow.
The thing is that the thing's 80 feet long, but it's got 27 miles of wires. So if you pin something wrong into the wrong bit, you could be chasing it for months.
Yeah. Now we have 5 more minutes left, but I want to go through some trivia from an expert, and you tell me true or false and comment on that.
Okay.
Number one, that vast majority of the accident happens during the takeoff in the aviation.
True.
Okay.
True. That is the most dangerous point of any flight. Landing is easy because you're already at speed. You're just trying to slow it down, and you're in control of the aircraft. But there is that point where during takeoff, as you start to rotate, where the aircraft is either going to leave the ground or it's not.
Now, rotate, for people who don't know, that is when you literally lose contact with the ground, right?
Correct. The nose lifts off, you rotate on the main gear, and then it will leave the earth. Yeah.
So, and then I have heard so many times if you have, God forbid, you have an accident, the safest place in airplane is the back of the airplane, not where the first class passengers are, but
Yeah.
the coach, the back of the airplane. Is that true?
Actually, for me, I've always heard it was over the wing box, between the wings.
Okay,
That
so
is structurally the strongest part of the aircraft.
okay.
And if an aircraft does, you've seen them in the past, that they've even cartwheeled, that's the strongest place that's going to stay together. So if I can get a seat, I always get a seat over the wings, because there's also the emergency exit there as well, so you can get out really fast.
Okay.
And
Yeah,
that
the
works.
first class passengers and the toilets at the back, they're toast.
Now, Amanda, do you have any question? I know you have traumatic experience. You want to talk about it?
No, I don't.
No,
I-
a passenger that I used to travel with a long time ago. We went from here to Dallas, and we had to go land. We had to go through a thunderstorm, and airplane was violently shaking.
Yes.
And is true or false that airplane is designed to go through that violent shaking and even be hit?
Absolutely.
Oh,
Absolutely. And then
Okay.
some.
I wasn't afraid. I wasn't afraid of the shaking. I was nauseous from the shaking. I wasn't
Yes.
afraid.
That will do it.
and then we had to do a go around, go through that thunderstorm yet another time. And then on the way back to Minneapolis, again, we had to go through a round around. How often does that happen that in one trip on both legs, you have to go, they call it go around, meaning that
Yes.
you land, something is not right, you take off again because that's the safest thing to do. And you consider for all the variation and you come back and land again.
Yep.
So,
But as for our aircraft and how strong they are, we do a thing called fatigue and damage and durability testing. And basically what we do is we build the structure of the aircraft in this massive rig, and we have to accomplish a certain amount by the time we go to fly. I think it's about 50% of testing, but the actual testing doesn't finish until we're already certified. And what we do is we literally stretch and pull and press and try to crush the structure. We do everything we can to break it.
on
And
the
we
ground, or you're doing that on the ground?
Yeah, it's a rig test. And there's a certain test. Once we have completed everything, they do the maximum braking test. And they actually take the wing of an aircraft, no matter how big it is, and they push it at the end until it snaps, because they want to see where the wing actually snaps. And that's the last test they do. And boy, that is something to witness when the wing actually finally goes.
Ooh.
But those things, these aircraft, they're so strong, they can take one hell of a beating and stay in the air.
No.
The most dangerous part of an aircraft when it's flying, and I mean this with the most respect, is the pilot. It's his response. It's the human response to an emergency situation that is the most critical thing of any flight.
Last trivia that I have heard, and you confirm or deny, is that in the last 20 years, most of airplanes, they have on the side of the wing a piece that goes up, winglet, they call
Yes.
it. That we copied that from the nature because the birds have something like
Exactly.
That
And
true?
that helps maintain a straighter flight. It allows the engines to actually not have to work as hard, because they keep it much straighter, and it's made a huge benefit in actually just saving fuel, just adding those little winglets, because the aircraft doesn't wobble like it used to.
I
So the
hear
engines aren't trying to overcome that.
I hear that's up to 7% of efficiency and less fuel by adding just those winglets.
Yes. Yeah, it's quite amazing. And that's where I work with flight sciences engineers, and we call them the black arts and the dark arts, because they're the ones doing all the computational fluid dynamic analysis and all of this to try and understand how the flow of the air will go over the airframe and the wings. And some of the stuff, when they start talking, I'm just like, okay, I'm just going to sit here and pretend I understand what they're talking about. But it's incredible how they develop the wings and the engines, and every leading edge that is going to face and push into the wind, how it needs to be shaped. and where it is on the aircraft. An engine inlet has a different shape and a wing leading edge, things like that. It's brilliant stuff. I can never get to the end of it.
Andy, your enthusiasm is contagious. I see that we definitely have to return to this and talk about that. And I officially like to invite your father to talk about his history. But that will be the essence of history. We have 4 podcasts: Essence of Science, Essence of Life, Essence of History, Essence of Medicine. I want to know the experience of Cuban crisis and the history of what you described, what happened there, but I could talk hours and hours about that, but we are getting through our time now. Thank you so much for being with us, Andy.
This has been a blast. Thank you so much for inviting me. I've never done this before. I was terrified. I even logged on at 1:30 to get everything set up, and I got all my lights all done. So I loved it. This was great. I'd love to do it again. Yes.
You'll be back.
Yeah, we'll be back. Well,
excellent.
Amanda, it's your turn.
Thank you guys for watching. This was Essence of Science. We talked about the technology that puts us in the clouds. I'm Amanda Armagost.
I'm Dr. Abbasi for Essence, and we have our special guest,
Andy Barlow.
Thanks, guys.
Bye-bye.
Have a good day.
Thank you.
And it was great to meet you.
You too.